figure. Replace this force and a couple with an equivalent single force. Means you have to find out the resultant of this force and couple. Now the board is visible?
Yes, sir.
Okay. Now here, 250 Newton meter anti-clockwise couple is acting at A. Couple is always constant, it is independent of the point about which it is taken. So I am transferring this 250 Newton meter couple from point G to point A without changing the effect. Now I am combining this force and couple. When a force is resolved into two parts, you will get a force and couple. Because when a force is transferred from one point to another point, that force is accompanied by a couple, right? Now when you combine the force and couple, resultant will be a force which will go back to its original position by a distance d given by m upon f. Are you getting my point? So when a force is transferred from one point to another point, that force is accompanied by a couple. But when you add that force and couple, resultant will be the original force, which will be transferred to its original position by distance d given by m upon f. So now when you add these two, the resultant of these two will be a force which will be transferred parallelly through a distance d given by m is 250 upon force is 100. So it is 2.5 meters. So when you combine 100 Newton force and 250 Newton meter couple, you will get a resultant force of 100 Newton acting at 30 degrees with horizontal at a perpendicular distance from point A of 2.5 meters. Have you understood?
So,
Yes.
so can you explain this thing once again?
Okay. Now see, there are 2 points A and B on a rigid body.
Sir,
Yes.
so whatever you made that mathematical thing that shows that the 250 Newton meter movement is by 100 Newton force.
Hmm.
Ah,
This only I would like to explain this concept only. See here, force P is acting at point A, which is to be transferred parallelly to point B through distance D. Now, when a force is transferred parallelly from one point to another point, that force is accompanied by a moment or couple whose magnitude is P into D. Is it clear? At B now, force and couple are acting. Now consider another figure. Now you are having force P at B along with a clockwise couple of P into D. Now when you transfer force P from A to B, this is the resultant. You are getting force and couple. Now when you combine these two, which are acting at B, the resultant will be a single force which will go back to its original position. When you transfer from A to B, you are having this resultant, force and couple. But when force and couple are combined at B, the resultant will be the force which will go back to original position through a distance D. D is equal to M upon P. The distance D is equal to M upon P. That's what we are doing here. We are adding force and couple. Then the force will be transferred parallelly by distance D is equal to the moment upon force. force. Moment is 250, force is 100. In which direction it will be transferred? So why not it will be transferred upside? That means say this is 100 Newton through a distance d. It can be transferred parallelly, either the upper side or lower side. How you decide? You can decide that from the sense of the couple. Here, what is the sense of the given couple? Anti-clockwise. So, if the 100 Newton is transferred to lower side, then only it can create anti-clockwise couple about point A. Suppose if you assume that it is transferred on the upper side, that force will create clockwise couple at point A. Are you getting my point? So you have to see the sense of the couple also. So it is transferred parallelly by distance 2.5 meters on the lower side, so that it can have the effect of anti-clockwise sense. Understood?
So point should be on body, no?
Sorry?
The point should be on the body.
It has to be on the body. This force, 100 Newton, must act anywhere along the line of action of this force, but on the body. Only thing we are saying is perpendicular distance is 2.5 meters. This is the line of action. So that force can act at any point on the line of action, but within the body.
Sir,
Yes.
Sir, but that question is
can you
different, no,
explain
sir.
that
They are
formula
asking
of
to.
D250 by 101?
Sorry. What is 250 by 100?
Hmm.
See, we know that moment of the couple is equal to force into perpendicular distance. So from this only we are getting a d is equal to m upon f. Here this distance d is equal to m is 250 upon f is 100. Initially, when a force is acting at point A, which is to be transferred to point B by distance d, you will have that force along with a couple. And what is the magnitude of this couple? It is force into perpendicular distance between the two lines of action. So at B you are having force and couple. Couple M is equal to F into D. Am I right? So from this you can have D is equal to M upon F. That is this D over here. So same thing over here. Here at B we are having S and couple. At A we are having F and couple. F is 100, couple is 250. So when you combine these two, that force will be transferred parallelly by distance d given by couple upon force. Couple upon force, that is 2.5.
Sir, the question is different, no?
What is the question?
They said the
We have to replace it.
they said the equivalent force of by adding that moment and force. That's why I'm asking the point at which the we have to calculate that moment.
Please read the statement once again. Please read the statement. Please read the statement of the problem. Yes, please. What is the statement of the problem? Anybody? Can you please read?
This force and couple with an equivalent single force.
So you have to replace the force and couple with an equivalent single force. Now see this figure. I have replaced the given force and couple with a single force of 100 Newton acting at a perpendicular distance of 2.5 meters from A. Now the question is where it is acting, right? For that, you can do like this. You extend the line of action of this force. Let us say this is point E, where the line of action cuts the line AB, and say it is F. I am saying with respect to A, this distance is X, and this vertical distance is Y. Now we have this as 30 degrees. Now I will call this point as H, this point. Now from the right angle triangle A, F, H. You see, from the right angle triangle A, F, H. You have this as
Sir, you are unfortunately calculating moment at point A. No?
calculating moment at point.
A.
No, I am not calculating, it is given. See, this 250 Newton meter couple is given, na? This I am not calculating, na? 250 Newton meter is given. You have to replace this 250 Newton meter and 100 Newton with single force. Here 100 Newton is acting at point A and 250 Newton meter is acting at G. I am replacing these two with only one force. That force is 100 Newton, which is acting at this position. It is the resultant of that force and couple. Now to define the position of this, we know the direction 30 degrees with horizontal, magnitude is 100, but where it is acting? To find out that, I am doing all this. We know that it is acting at a perpendicular distance 2.5 meters from A, but where it is acting? So I am defining that position by X and Y. So from this right angle triangle, you have this as B. Now you have this as X. So sine 30 is equal to B upon X. But B is equal to 2.5 upon X. Now tell me what is the value of X? What is the value of X?
5 meters.
Sorry? 5 meters? It is 5 meters. Now from the right angle triangle A, B, F, you have this as Y, this is X, you have 30 degrees. Now tan 30. Tan 30 is equal to Y upon X. X is 5. What is the value of Y? Two point 885, right? So now I can define the point where that force is acting. We can say that this force of 100 Newton is acting at point E at a distance of 5 meters from A horizontally. Or you can say that the force of 100 Newton is acting at F at a distance of 2.885 meters vertically. Or the force is acting at point H at a perpendicular distance of 2.5 meters from A. So to define the point where it is acting as per principle of transmissibility of forces, if a force is acting at a particular point, that force can be assumed to act at any other point along the same line of action. So from F to E, you can consider any point on the line of action to define where it is acting. Is it clear? That means we have replaced this 100 Newton force acting at A and couple acting at G with single force. What is that single force? 100 Newton. But where it is acting? It is not acting at point A. It is acting at a perpendicular distance of 2.5 meter from A. Horizontal distance of 5 meter from A. Vertical distance of 2.885 meter from A. So any one of these distances x, y or d will be sufficient to define where the force is acting. 35 Newton vertical force P is applied to the bracket at A as shown in figure, which is held by two screws at B and C. So first you have to replace force P with an equivalent force couple system at B. In the second part, you have to find out the two horizontal forces at B and C that are equivalent to the couple obtained in part 1. So it is an angle bracket, force P of magnitude 135 Newton. It is acting vertically downwards at point A. So the first part is you have to replace this force with equivalent force couple system at point B. Means what you have to do? Simply find out moment of force about point B. So what is the moment of force about point B? It is creating anti-clockwise sense 135 into perpendicular distance is 125. That's all. 135 into 125.
Sixteen point eight seven five.
16.875. What are the units?
Newton meter.
Sir, 875.
Anti-clockwise. Right?
You have written 785.
875, sir. 16.87.
Sorry. So the answer for the first part A, B, C. So that 135 Newton is transferred parallelly. So force is 135 Newton. So when it is transferred parallelly, that force is accompanied by a couple. This couple is anti-clockwise sense of magnitude 16.875 Newton meter. So this is our answer for the first part. Replacing with P with equivalent force couple system at P. Now the second part. You have to find out two horizontal forces at B and C. Two horizontal forces at B and C that are equivalent to the couple obtained in part 1, that is 16.875 Newton meter anti-clockwise. Now, here you have to apply two horizontal forces in such a way that these two forces will form an anti-clockwise couple. For that, what should be the direction? At B, the force must act towards left, and at C, it is acting towards right. Right? So it is FB, FC. The distance between them is 75 millimeters. So we can say that two equal and opposite parallel forces are said to form a couple. That means here FB is equal to FC. Then only these two forces will form a couple, right? Is equal to F. Now you tell me what is the moment of this couple? Here it is anti-clockwise. F into perpendicular distance between them is 75 millimeters, 0.075 meters. So this moment of the couple is equal to 16.875. That are equivalent to the couple obtained in part 1. This gives you force F.
225.
225. So what are your answers? So the second part, FB is equal to 225 Newton acting towards left. FC 225 Newton which is acting towards right. Two horizontal forces and B and C that are equivalent to the couple obtained in part 1. Forces exerted on the cross section of a steel channel are shown in figure. We place this system of forces by an equivalent single force at point G and determine the distance x of point G from point C. Can anyone explain how we can solve this problem? See, there are three forces are acting on the channel cross section. Two 2000 Newton forces and one 750. But these 2000 Newton forces are forming a couple. They are parallel to each other, magnitude is same and opposite sense. So you can replace these two parallel forces with a couple of magnitude 2000 into perpendicular distance between them is 75 plus 75, 150. And what is the sense of the couple? Yes, please, it is clockwise.
Clockwise.
It is acting towards right, left. So it is forming clockwise couple. So it is 2000 into 150. 4 minus Newton milliliter. That means it is 300 Newton meter clockwise. Right? 300 Newton meter clockwise. So the equivalent system will be, there is a force of 750 Newton acting vertically downwards. And there is a clockwise couple of magnitude 300 Newton meter. Simply I am replacing these two parallel forces with a couple. That's all. Okay. Now I will combine this force and couple. When a force and couple are combined, resultant will be a force which will be transferred parallelly by a perpendicular distance d given by moment upon force. But this perpendicular distance is nothing but x. Understood? So it is 750 Newton. is equal to 300 upon 750. So this is couple upon force. 300 upon 750. Sorry.
0.4, sir.
It is 0.4 meters. Right? So x is equal to 400 millimeters. So the resultant of the given system is 750 Newton, which is acting at a distance of 400 millimeters from point C. So this is our answer.